Welcome back everybody, I'm Dave and today we are going to go through product rules. So this is part of differential calculus. It is when we have to differentiate an expression that has the product of two functions with respect to x. So if we have a quick look at the formula here, we have to differentiate with respect to x, u times v. So we'll look at a question in a moment, how do we define what u and v are? But in order to do that, we'll take u and multiply it by the derivative of v, and then we'll take v and multiply it by the derivative of u.
Boy, that escalated quickly.
Okay, so what does that actually mean? Well, when we see a question, I will define what u and v are, and then we'll be able to perform the product rule, which appears in the formula booklet if you're part of IB, but otherwise you'll have to remember it if you're in another course. So let's have a look at this question here. So if y is defined by x to the 4 multiplied by 1 minus 2x all squared, then what we want to do is try to think of this as being in two parts. Okay, so this is like u, so let's get rid of this line here. This is u, and the right hand side is v. Okay, and we need to differentiate y with respect to x. So let's go ahead and write down the product rule. So we have y prime, so that's dy by dx, is equal to v times the derivative of u plus u times the derivative of v. Just have a look at the formula at the top of the page. So let's go ahead on the right hand side and define what u is. So u is x to the 4. Now how do I know that? Well, where does the actual multiplication occur? Where does the multiplication in this expression sort of appear? So it's actually here, right, where I've put this pink dot, because this is x to the 4 multiplied by this whole bracket. So this is why we want to separate this expression into the sort of the left hand side and the right hand side. So u is equal to x to the 4. Now when I differentiate u with respect to x, I will get 4x cubed, okay, using simple power rule. Now the expression v is a little bit more complicated because v is equal to the whole bracket, right, 1 minus 2x all squared. Now in my other video, if you look at my playlist on calculus, we will have to differentiate this and we will need to use chain rule. And the quick version of the chain rule would be the following. We multiply by the power, everything in the bracket stays the same. We drop the power down by 1, so we take 1 off the power, so that would become 1. And then we must multiply by the derivative of the bracket. So that is the thing quite a lot of people forget to do. And the derivative of this bracket here is negative 2. So let's just simplify that up. That would be 2 times minus 2, so minus 4. Then we have the brackets 1 minus 2x. Okay, so this is the derivative of a bracket, and we have actually used chain rule to do that. So we have to do that before we even start the product rule. So off we go now. Once we've got all our expressions here, we are going to put them into the product rule formula. So y prime is equal to v, so we go over to the right and we just extract what v was, which is 2x squared, times by the derivative of u, which was 4x cubed, plus u, which was x to the 4, times by the derivative of v, which was minus 4, okay, 1 minus 2x. Now, if you notice, I'm being quite careful with my brackets here. I'm trying to keep things together so things don't get split. But now I would actually, that is really the result, because I don't have to substitute a number into that. But it's just good practice to tidy this up, but just make sure you don't make any mistakes when you tidy this up. So I'm going to put 4 at the front. Then I'm going to have my power of x. Then I'll have my bracket. And same thing on the right. I can see that there's a negative here, so it's x to the 4 times minus 4, so this would be in minus 4, x to the 4, and then my bracket. Now, you can probably argue that I could times that out of the bracket and write it, but it's not really necessary. And most likely in an exam question, you would need to now substitute a value in to actually calculate the gradient at a given point. But that is the answer to question 1. Okay, question 2. It is similar to the previous one. I have a square root and I will need to substitute a value in for x in order to find the actual gradient at a given point. So let's go ahead and rewrite this expression, y is equal to x. Now, this is another indice rule problem where you will need to change this to a half. So I hope that you know the rule that the square root can be changed into a power of half. Let's go ahead and split this up into two parts, u and v. This is very similar to question 1, where we would say, okay, well, let u equal x, therefore u prime is just 1. Therefore then v is equal to 1 minus 2x all raised to the power of a half. So when we differentiate v with respect to x, we need to now use chain rule again. So we times by the power, we will subtract 1 from the power, so that will make that minus half. Then we times by the derivative of the bracket. So the derivative of the bracket would just be minus 2. Now, before we go any further, I can see that a half times minus 2 will be minus 1 or negative 1. So this whole expression will just be negative 1 times 1 minus 2x to the minus half. Now, you may want to put that back on the denominator because it is a negative half, so that is like 1 over the square root of this expression, but I'm not going to go that far just yet. Let's take it in sort of slow steps to begin with. So now I'm going to write down what the product rule is, and it's v times derivative of u plus u times the derivative of v. Let's go ahead and substitute everything in. So we have v, and I'm using these values on the right hand side. I'm just substituting them in to the formula as I see them. So we have 1 minus 2x raised to the power of a half times by the derivative of u, which is just 1. That's nice. U, which is just x, times by the derivative of v, which is negative. So this whole expression actually is going to be negative. So I'm going to change that plus now to a minus. I've put that in pink so you can see what I did, because it is a negative. 1 minus 2x, okay, all raised to the minus negative half. Now, what the question stated was substitute minus 4 into this expression. So let's have a look at how that will work. Now, I think at this stage here, it's important to, this is why you need to know your indices rules, is that I'm going to rewrite this, but without the power of a half, so you can see a little bit more clearly what's going to happen. So we have y prime is equal to the square root of 1 minus 2x times 1, so the 1's can sort of disappear at this stage, minus, now this is the slightly tricky part, okay, this would become x over the square root of 1 minus 2x. Now you can see a little bit more clearly about what's going to happen when I substitute minus 4 into this. So it will be root 1 minus, now 2 times minus 4 is minus 8, so it'll actually be plus 8 minus, and then we're putting minus 4 in for x, so I'll just put that in brackets just for the time being, over, and then we have exactly the same thing here, oops, that would be root 9 again. Okay, so this will become root 9, which is just 3, plus 4 over 3. Okay, so we can say that this is over 1 times top and bottom by 3. So that would become 9 over 3 plus 4 over 3. So that would equal 13 over 3. And that's our answer for part 2. Okay, let's have a look at question 3. So find the x-coordinate of all points on y equals root x, 3 minus x squared, where tangents are horizontal. Okay, so first thing to note here, if tangents are horizontal, that means that the tangents have a gradient of 0. Okay, a horizontal tangent has a gradient of 0. It's just flat. Okay, so what we'll need to do then is differentiate this function with respect to x using product rule, and then equate that gradient function that we get to 0. Okay, and therefore then we will solve for x for when the gradient is equal to 0, therefore finding the tangents that are equal to 0. So let's go ahead and do that now. So we have y is equal to root x. Now I'm going to use change the square root to a power of a half, which is your indice rules that you should know about. And then we have 3 minus x squared. So just like questions 1 and 2, we're going to call this u and this v. So we can go ahead and differentiate these independently. So u equals x to the half. Therefore, the derivative of u, so u prime, is times by the power, take 1 off the power. Okay, and now we'll go ahead and do the same for v. So v was equal to 3 minus x squared. Remember, the whole thing is v, not just what's inside the brackets, but the entire thing. So we will now need to use chain rule again in order to differentiate this. Now, you could expand the brackets and then differentiate each term independently, but I'm just going to use chain rule. So it's times by the power, take 1 off the power, so I'll just go down to 1, and then times by the derivative of the bracket. Now, the derivative of the bracket will just be negative 1. Okay, so this will just result in negative 2, 3 minus x. So that will be the derivative of v. Okay, so let's go ahead and plug all of these values into the product rule formula. So y prime is equal to v times the derivative of u plus u times the derivative of v. So looking to the right and just literally substituting them in as I see them. So v is 3 minus x squared. Derivative of u will be half x to the minus half. Now, I'll just put minus half now, then in the next line down, I'll tidy it up. Plus u, which is x to the half, times dv, which is minus 2, 3 minus x there. Okay, so I'm going to put that down because if there were method marks available, I should be able to get method marks here, and then if I make a mistake in this next step, that wouldn't penalize me too much. But I'm going to bring the coefficient to the front, half. On the numerator, I'm going to put 3 minus x squared, and then on the denominator will be root x. Okay, so that little step there, you want to be a bit careful of, because I'm putting this x to the minus half back on the denominator and putting the root back on it, because when I substitute a value in, or I have to equate some value, I like to see it more as a square root. It's just a little bit easier to deal with, I believe. Right, so the next part will be minus 2 root x. So again, I'm converting the indices back to square roots, times 3 minus x. Okay, now that is dy by dx. Okay, so I'll just put that around here. Now I want to solve the problem where values of x which would lead to the gradient being equal to 0. Okay, so when we see this here, I want to equate this value to 0. Okay, and then I'll be able to solve for x to find when exactly, what values of x would give me a 0 gradient. Okay, so when I look at this here, there's many ways that you could do it, balancing the equation either side. But I'm going to I can see that I have a denominator of 2 root x. So I'm going to times everything through by 2 root x. Timesing 0 through by 2 root x would remain as 0. If I times this first fraction, right, by 2 root x, then the 2 root x will cancel with the 2 root x on the bottom. Timesing this part of the expression by 2 root x would result in 4 x, okay, so 2 root x times 2 root x is 4x, and that'll be 3 minus x. So therefore, then I'm starting to simplify this. Now, what's important here is that you probably don't want to start dividing through by values, because you may lose some of the answers. So this is as a rule of thumb, try to factorize where possible, especially when it's equating to 0. So if I try to factorize this now, I can see that on the right there is a common factor of 3 minus x in both of these. So I'm going to take a 3 minus x outside. I'm going to introduce some larger brackets just so it's a little bit more visually easy for you to see. But 3 minus x times 3 minus x would equal 3 minus x squared. And then 3 minus x times negative 4x, okay, would equal this sort of second expression. Like we can times in using the FOIL method, and we realize that we get both of the terms above. So now what we want to do is solve for x. So I can see that in this bracket outside, if x was equal to 3, then this expression will be 0, this bracket will be 0, so the whole thing will be 0. So that's good, that's one of my results. And now I just need to solve for x on this here. So I want this thing to be equal to 0. Right, so let's set that up. So 3 minus x minus 4x has to equal 0. So we would have 3 minus 5x has to equal 0. So 3 equals 5x, and therefore x is equal to 3 over 5. And that is our second solution. Good luck. Don't forget to like and subscribe to the channel. When new content drops, you'll be the first to know about it. On the left, click the video for more tutorials. I'll see you next time.